Photons' epic journey. Here the matter of discussion is why photon particles created in the core of sun takes so much time to reach to the outer layer of the sun, from where the photon particles propagate in the outer space to illuminate the solar system, and whose impact on Earth is known to you. So photon particles after creation in the core of sun takes so much time to reach from the core region to the outer layer, which is known as photosphere, means to the surface of the sun. So much time is involved. So how these photon particles are created inside the core of the sun, this is known to you. Nuclear fusion reaction takes place inside the core region of sun, where hydrogen nuclei are converted into helium nuclei by nuclear fusion reaction. So during this conversion process, high energy gamma ray particles are created. High energy gamma rays are created, which are nothing but photon particles with high frequency. Because high energy is involved, so frequency will be naturally high. So high energy gamma ray particles or the high energy gamma ray photons are created inside the core region during the nuclear fusion process. Okay, so after the creation of this tries to go outward. Photon particles try to go outward. Okay, but it's not easy because vacuum is not there. The diameter of sun is just 4.36 times than that of the means actually if light passes along a straight line along the diameter of the sun, and if there is no obstacle, means if it is completely vacuum, then it takes only 4.3 second time. So what is the diameter of the sun? It is nothing but 4.36 multiplied by 3 into 10 to the power 8 meter. That is the length of the diameter of the sun. But time involved for the photon particles, or the time required for the photon particles to reach from the core region to the photosphere of the sun or the surface of the sun is so much. Okay, why? Because outside the core region, which is known as a radiative zone extends from the outer layer of the core region up to the 70% of the radius of the sun. That is the radiative zone. This radiative zone, what is there? There is plasma. Mostly protons and electrons are there. Density is extreme. Pressure is extreme. Temperature is extreme. Density, pressure and temperature all are extreme in the radiative zone of the sun, which starts from the outer layer of the core region of the sun and extends up to the 70% of the radius of the sun. This is the core region, and there are charged particles, mostly protons and electrons. You know, protons are positively charged and electrons are negatively charged particles. So in this environment, photons are there, high energy gamma ray photons are there. So these photon particles cannot go in a straight line direction. Okay, the photon particles continuously collide with the particles inside the radiative zone. So here diffusion takes place, diffusion of photon particles, and it takes so much time. Diffusion process is so slow, it is not fast. Diffusion process, this diffusion process of photon particles inside the radiative zone is known as radiative diffusion, because here first emission takes place, then absorption, then again re-emission. That's why this is known as a radiative diffusion. Not only diffusion, but radiative diffusion. Okay. And while these interactions are taking place, means scattering of the photon particles are taking place. Okay. The photon particles lose their energy during this diffusion process. And ultimately, these high energy gamma ray photon particles become normal photon particles, which is known as light, the visible light. Means they lose energy during the diffusion process because the photon particles are continuously interacting with the surrounding plasma. And while doing this, they are losing their energy. So ultimately it takes so much time to reach to the outer surface of the sun, and then emission of those photon particles takes place as light rays. And then it goes to the outer space. It illuminates the solar system. Some part of the solar rays falls on Earth, okay, and everything is known to you. After that, what happens? Everything is known to you, and this is very interesting topic in astrophysics, okay, or solar physics. For the forecasting of weather, nature on the planet Earth, this knowledge is required. Means sun's dynamics needs to be known by the physicists to predict many things. Whether in the outer space, that is also the requirement. Okay, so to study all those things, this topic is discussed, and this topic is discussed under the subject heading of solar physics, or the broader area of research is astrophysics. Anyway, so this was all about the epic journey of the photon particles. Okay, so this is the end of this video. Thank you for watching this video.